Welcome. In this video, we're going to work through the solutions of activity 5.2.4. So let's start off with part A. We have the derivative of the integral from 4 to x of e to the t squared dt. And we want to evaluate this using the first fundamental theorem of calculus or the second fundamental theorem of calculus. So over here on the right, we have the first fundamental theorem of calculus, and the second one is below it. And you'll notice in the second fundamental theorem of calculus, we've got the derivative of an integral, and that's exactly what we have over here in part A. So what we want to do is to match up the different parts. Notice we have an integral here from 4 to x. Here we have an integral from c to x. So for part A, our c is equal to 4. And we have our integrand is a function of time. And over here, our integrand is e to the t squared. So we have f of t is equal to e to the t squared. So if we write, what is the derivative with respect to x of the integral from 4 to x of e to the t squared dt? Well, that's just the derivative of the integral from c to x of f of t dt. And by the second fundamental theorem of calculus, that's equal to f of x. So in this case, all we have to do is just substitute x for t in our formula, and we get e to the x squared. So the answer to part A is e to the x squared. B looks a little bit different. Instead of having the derivative of an integral, we have the integral of a derivative. So that looks a lot more like the first fundamental theorem of calculus. So we have the integral from c to x. For part B, the integral from -2 to x. So for part B, we have our c value is equal to -2. And then we have the derivative of some function. In this case, our function is t to the fourth over 1 plus t to the fourth. So we'll write that down. So when we substitute these into part B, we get the integral from, in place of -2, we're going to put c. And we have x is our upper limit of integration. The derivative of, in place of t to the fourth over 1 plus t to the fourth, we're going to put f of t. Over dt. And by the first fundamental theorem of calculus, this is equal to f of x minus f of c. So to find f of x, we simply replace each t with an x, and we get x to the fourth over 1 plus x to the fourth, and then minus f of c. F of c will be f of -2. So let's calculate that over on the side here. F of c is f of -2. That's equal to the fourth power of -2 divided by 1 plus the fourth power of -2. And the fourth power of -2 is 16 over 1 plus 16 is 17. So when we're subtracting f of c, we're subtracting f of -2, and that is 16 over 17. So the answer to part B is x to the fourth over 1 plus x to the fourth minus 16 over 17. For part C, we're back to the derivative of an integral. So that's looking a lot like the second fundamental theorem of calculus. But notice this time, instead of having the integral from a constant to x, we've got the integral from x to a constant. So for this one, we want to recall a property of integrals that says the integral from a to b of f of x dx is equal to the opposite of the integral from b to a of f of x dx. So if we want to switch the lower and upper limits, we just have to pull out a negative sign from our integral. So for part C, we might start by writing that this is the derivative of minus the integral from 1 to x of cosine of t cubed dt. And using properties of derivatives, we know that the derivative of a constant multiple is the constant times the function. So in this case, we can pull out the negative and we get minus the derivative of the integral from 1 to x of cosine of t cubed dt. And so now we have the derivative of an integral from a constant to x of a function of t dt. So like example A, all we have to do is just replace the t in our integrand with an x. So for this one, we get minus cosine of x cubed. That is the answer to part C. For part D, we're back to the first fundamental theorem of calculus. So the first thing we want to do is to find an antiderivative of the integrand. And since the integrand involves a derivative, the antiderivative will just be this inner function here, the natural logarithm of 1 plus t squared. So we're going to write the natural logarithm of 1 plus t squared. And we'll want to evaluate that from 3 to x. So we take the x and substitute it in, and we get the natural logarithm of 1 plus x squared. And then we subtract what we get when we substitute in the lower limit. So we get the natural logarithm of 1 plus 3 squared. And this simplifies to the natural logarithm of 1 plus x squared minus the natural logarithm of 1 plus 9, which is 10. So minus the natural logarithm of 10. So for part D, this is our final answer. And for part E, we're back to the derivative of an integral. So it looks like we're going to be working with the fundamental theorem of calculus part 2 again. This one's a little bit tricky because instead of having the integral from a constant to x, we've got the integral from a constant to x cubed. So for this one, I'm going to suggest that we make a couple of substitutions. Let's y be what we're taking the derivative of. So let's let y be equal to the integral from 4 to x cubed of sine of t squared dt. And let's let u be equal to the upper limit of integration, which is x cubed. So by doing that, we could rewrite this as y is equal to the integral from 4 to u of sine of t squared. So notice here we've got u is a function of x and y is a function of u because the upper limit of integration is a u instead of x. So right here, if we go back up to part E, what we have is we've got d dx, and then in brackets here we have the derivative of y. So in other words, this is equal to dy dx. But we know from the chain rule that dy dx is equal to dy du multiplied by du dx. So what is dy du? Well, we're going to look at this part right here. Okay, we have the integral from 4 to u of a function of t dt. So the second fundamental theorem of calculus says that dy du is just equal to the sine of u squared. And then we need to multiply that by du dx. So we have u is equal to x cubed, du dx is equal to 3x squared. So finally we substitute. We want our answer in terms of x. So if u is equal to x cubed, then we have the square of x cubed, and we get sine, I'll go ahead and write it out here. We have sine of the square of x cubed and we could write this as 3x squared multiplied by the sine of x to the sixth. So this is our final answer.